Ever tried snapping a photo in the dark, only to end up with a blurry, grainy mess? You're not alone. Low-light photography has been a persistent challenge for cameras and algorithms alike. But what if we could transform those murky, underexposed shots into crisp, vibrant scenes? Let's explore how researchers are tackling this problem, and why their new approach, CIVQLLIE, is rewriting the rules of image enhancement. For decades, fixing low-light images relied on basic techniques like boosting brightness or adjusting contrast. Think of it as trying to fix a bad photo with a magnifying glass, limited results at best. Then came deep learning, where neural networks learned to see in the dark. But even these methods had flaws: rigid pipelines, struggles with complex lighting, and assumptions that didn't hold in real-world scenarios. Enter CIVQLLIE, a revolutionary framework that's redefining low-light image enhancement. Unlike traditional approaches, it doesn't just guess what a dark image should look like. Instead, it uses causal reasoning to identify why the image is poor in the first place. Imagine diagnosing a broken lamp. You don't just replace the bulb blindly. You trace the root cause, wiring, socket, or bulb. CIVQLLIE does the same. It pinpoints the lighting issues and fixes them systematically. Here's the magic. CIVQLLIE starts by building a codebook of high-quality, well-lit images. Think of it as a digital library of visual gold standards. When it encounters a dark photo, it doesn't just brighten it randomly. Instead, it compares the image to this codebook and asks, what's missing here? But low-light images are often so distorted that direct matches fail. That's where vector quantization steps in, a smart search engine that finds the closest possible match, even if the image is warped or noisy. But fixing the big picture isn't enough. That's where pixel-level causal intervention, PCI, comes in. This module acts like a precision tool, adjusting brightness, color, and texture at the pixel level. It's not just about making things brighter, it's about restoring natural balance. For example, if a shadow is too dark, PCI gently lifts it without making the entire image look artificial. Next up is feature-aware causal intervention, FCI. This part uses low-frequency selective attention, gating to zero in on the most lighting-affected areas. Think of it like a detective focusing on the most suspicious clues. If a face is blurry or a background is overly dark, FCI targets those regions specifically, enhancing them without disrupting the rest of the photo. Finally, the high-frequency Detail Reconstruction module, HDRM, adds the finishing touches. After adjusting brightness and color, images often lack sharpness or texture. HDRM uses deformable convolutions, a technique that adapts its tools to the image's unique features. It's like a painter adding fine brushstrokes to bring out details in a portrait, making textures, edges, and patterns look natural. The results? Let's break it down. At its core, CIVQLLIE builds on a model called VQGAN, which functions like a digital artist's brain. Imagine training a neural network to recognize and store the essence of high-quality images in a codebook, a library of patterns, like how light dances across a sunset or how shadows define a face. The model learns to translate images into this secret language, then decode them back into visuals. It's like teaching a robot to paint by memorizing thousands of masterpieces. But here's the key: CIVQLLIE doesn't just copy. It understands. The system uses vector quantization, VQ, codebooks, a library of high-quality image features trained on thousands of well-lit photos. When it sees a dark, grainy image, it doesn't guess what to fix. It checks the library, compares the scene to the patterns it's learned, and knows exactly how to restore it. So how does it know what to fix? That's where causal analysis comes in. Instead of assuming a photo is dark because of low brightness, the system asks, what's the real cause? Is it overexposure? Poor lighting? A combination? By identifying these root causes, the AI targets the problem directly. For example, if a scene is too dim, it boosts brightness without warping colors or creating fake details. It's like adjusting a recipe by tweaking the main ingredients, not just adding salt. The real innovation. CIVQLLIE adds two smart tools, PCI and FCI modules, that help the AI match low-light images to the codebook more accurately. These modules act like fine-tuning knobs, ensuring the AI doesn't just guess, but understands the correct color and brightness patterns. Then the decoder gets a boost from HDRM layers, which act like a magnifying glass, revealing tiny details the codebook might have missed, subtle textures, hidden shadows, even the faintest glint of light. And how do they make sure it all works? The team designed a composite loss function, a set of rules that guides the model during training. Think of it as a checklist. 1. Pixel loss ensures the final image looks sharp. 2. Codebook loss keeps the AI aligned with its library. 3. Perceptual loss makes the image feel natural to the human eye. 4. Adversarial loss tricks the model into producing realistic textures. The result? Images that aren't just clearer, but more authentic. No more artificial color shifts or blurry edges. Just natural, lifelike details, even in the darkest scenes. So next time you're snapping a photo in the dark, remember, behind the scenes, AI is working like a digital detective, using libraries of light, causal clues, and smart algorithms to turn shadows into stories. And that's the future of image enhancement, where technology doesn't just fix pictures but understands them. What do you think? Would you trust AI to restore your most important photos? Let me know in the comments, maybe we'll dive deeper.